This is the budding light of hope and knowledge, the delight of Sri Prakash educational institutions, spreading academic brilliance in all directions.
Hi students, welcome to Sri Prakash Educational Institutions online video content. This is Vinod and I'm going to explain a topic of motion from class 9th, chapter 8, and this is the first video of the lesson. Instructions to be followed. Be ready with your textbook, notebook and pen. Watch and listen to the video carefully. Jot down all the important points in your notebook. In today's agenda, we are going to learn the word of the day, previous knowledge, definitions of important terms in motion, SI units of physical quantities related to motion, and summary. Word of the day, acceleration. It's a noun meaning the increase in something's speed or its ability to go faster. Conjugations, accelerate, accelerated, accelerating, accelerates. Usage, the car delivers quick acceleration. Learning outcomes. By the end of the session, the students will be able to understand the different terminology used in motion lesson, identify the relations between different physical quantities related to motion, understand the difference between vector and scalar quantities.
Namaste students, this is Vinod, your physics teacher. In this module, we are going to learn the important terms in motion. You have already learned motion in your previous classes. So you know how to calculate speed, you know how to convert the units from kilometer per hour to meter per second. In this module, we will concentrate on the important terms which you come across when you go through the lesson. Distance, displacement, speed, velocity, acceleration. So in these you will be also able to identify the scalar and vector quantities. Now, when you are going to the module, take your textbook and maintain a notebook along with that. Whenever you come across a definition, make a note of it, take the formula and write the units. Also, in your textbook, you have example questions and exercise questions related to the terms discussed here. So try to solve them. All the best.
Motion. In our everyday life, we see some objects at rest and others in motion. Birds fly, fish swim, blood flows through the veins and arteries, and car moves. Atoms and molecules move. The planets revolve. So, motion is related to the change in position of an object. So in definition of motion, it is a body is said to be in motion if it changes its position with time with respect to its surroundings. Rest. If an object does not move and remains stationary, it is said to be at rest. So if the position of an object does not change with the time and with respect to the surroundings, it is said to be at rest. Uniform motion. The body is said to be in uniform motion if it covers equal distances in equal intervals of time in a straight line. So there is a condition that this word should be equal in equal intervals of time and the body should move in a straight line. So it is possible only for a few cases. So consider the case of a train moving along a straight bridge with a uniform speed. Then its motion is said to be uniform motion. Non-uniform motion. In our daily life, we come across this situation where in traffic vehicles move in helter-skelter in different directions with different speeds. So a body is said to be in non-uniform motion if it covers unequal distances in equal intervals of time or equal distances in unequal intervals of time. Distance. We come across this term in our day-to-day life. We ask people distance between two places distance from our place to another place, distance between two cities, distance between two countries. When we travel, we check the odometer to find the distance. On the roadside, we also see the milestones which will give the distance between the towns. So here, an example, on the milestone you can see Mangalore 200 kilometer. So the distance of Mangalore from that place is 200 kilometer. It indicates that if you go along the length of the road for 200 kilometers, you will reach Bangalore. The direction is not mentioned. So from the definition, distance is the actual length of the path traversed by the moving body. So it is just the length of the path. It is a scalar quantity because the direction is not mentioned. SI unit of distance is meter. Displacement. Displacement is the shortest distance between the initial and final positions of the moving body in a particular direction. It is a vector quantity. Since direction has to be specified, displacement is considered to be a vector quantity. SI unit of displacement is meter. For distance also we have the SI unit as meter. Now to avoid any kind of confusion between distance and displacement, you can watch this video.
When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered will be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made two separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the two cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance travelled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and traveling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.
Students, after watching this, you will have a clear idea on what distance and displacement is. So, distance is the actual length of the path. Displacement depends only on the initial and final positions. And direction need to be considered. So, it is the shortest distance between initial and final positions. Now, we will continue to watch the difference between distance and displacement.
Distinction between distance and displacement. Distance. It is the actual length of the path traversed by the object. Displacement. It is the shortest distance between the initial and final positions of the body in a particular direction. Distance. It is a scalar quantity, that is, it has only magnitude. So for distance, no need to specify the direction. Just the actual length of the path is sufficient. Displacement. It's a vector quantity, that is, it has both magnitude and direction. So the change in position along with the magnitude, the direction has to be specified for displacement. Distance. It depends on the path followed by the object. Displacement. It is independent of the path. It just depends on the initial and final positions of the object. Distance. It is always positive because it is a scalar quantity and it has only magnitude. Displacement. It can be positive, negative or zero depending on the direction. So displacement, if it is along a positive direction, imagine like positive x-axis, it will have a positive value. And in the opposite direction, along the negative axis, it has a negative value. And if the final and the initial positions coincide, that is, the object returns to its starting position, then the displacement can be zero. Speed. We are all very familiar with speed. See here the example in the image what you have seen, the speed of the bike is greater than the car. So we are comparing in the same given time interval, the bike is able to cover more distance. That's why its speed is more. So speed is a comparison of distance traveled with the time taken. So according to definition, speed of a body is defined as the distance traveled by it in unit time. The formula is speed is equal to distance by time. So the symbol for speed is V equal to S by T. The SI unit of speed is meter per second, or m/s, or m s power minus 1. Uniform speed. Just like uniform motion, if the speed of an object remains constant, that is, if the object covers equal distances in equal intervals of time, then it is said to move with uniform speed. Example, a ball rolling on a smooth frictionless surface. Non-uniform or variable speed. This we come across in our day-to-day life. So consider this small video where the car initially accelerates, and then when the vehicles in front of it are moving slowly, it has to reduce the speed. Since the car cannot move with the same speed throughout its journey, it is said to be in non-uniform motion, or it is said to move with non-uniform speed or variable speed. So it happens when the vehicles move in traffic. Instantaneous speed. Speed at that instant of time is called instantaneous speed. When we travel in vehicles, the speedometer of the vehicle will give the speed at that instant of time. So according to definition, it is the speed of a body at that particular instant of time. The speedometer of a vehicle measures the instantaneous speed. Average speed. It is the ratio of total distance traveled by the body to the total time of journey. Take an example that we are traveling from town A to town B. If the distance between the two towns is 100 kilometers and the time for the journey is 2 hours, then the average speed for the journey is total distance is 100 divided by the total time is 2. 100 by 2 is equal to 50 kilometer per hour. So that is the meaning of the average speed. The formula for average speed is total distance traveled by total time taken. Velocity. The velocity of a body is the distance traveled per second by the body in a specific direction. So, speed is the distance traveled per unit time. Velocity is the distance traveled per unit time, but in a specific direction. When a direction is also included in the definition, then it's a vector quantity. So, velocity is a vector quantity, speed is a scalar quantity. The rate of change of displacement of a body with time is called its velocity. Since distance along with the direction we can say displacement, so the definition of velocity can be also written as the change of displacement with time. So the formula for velocity is equal to displacement by time. SI unit of velocity is same as the SI unit of speed, which is meter per second. Uniform velocity. If a body travels equal distances in equal intervals of time along a particular direction, the body is said to be moving with a uniform velocity. But there are rare chances that the body moves with the same speed in the same direction. So uniform velocity is not possible in a real-time case. But here, if you observe the raindrops falling down in the straight direction in the absence of wind can be considered as traveling with uniform velocity. Non-uniform or variable velocity. Most of the moving objects which we see around us move with non-uniform or variable velocity. So velocity is considered to be changed if the direction of motion changes or if the body do not cover equal distances in equal intervals of time in a particular direction. In both the cases, the velocity is said to be variable or non-uniform. According to definition, if a body moves unequal distances in a particular direction in equal intervals of time, it is a case though the direction is same but the distance covered is unequal, then it's a variable velocity. Or it moves equal distances in equal intervals of time but its direction of motion does not remain the same. It is the case though the magnitude of distances that is covered is equal in equal intervals of time but the direction does not remain the same, then in such a case the velocity is considered to be variable. Instantaneous velocity. Velocity of a body at that particular instant of time is called instantaneous velocity. Average velocity. It is the ratio of total displacement of the body to the total time taken. So the formula is average velocity equal to total displacement by total time. Average velocity, special case. If the velocity of a body changes at uniform rate, then average velocity is given by the arithmetic mean of initial and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity by 2. So we are going to take the mean of initial and final velocities. It is a special case because you cannot apply this for all cases. Only if there is a uniform change in the velocity, either the velocity increases or decreases uniformly, then we can apply this formula. Distinction between speed and velocity. Speed, the distance traveled per unit time by a moving object, is called speed. Velocity, the distance traveled per second by a moving object in a particular direction, is called velocity. Speed, it is a scalar quantity. Speed does not tell us the direction of motion. Velocity, it is a vector quantity. So when vectors are defined, both direction and magnitude is required. So velocity gives us the direction and the speed. Speed. The speed is always positive. Since it's a scalar, only the magnitude is considered. So as the vehicle moves, it will always have a positive value for speed. Velocity. Velocity, as it is a vector quantity, it can have both positive, negative and zero values depending on the initial and final positions and the direction of motion. Acceleration. Here in the image you can see the train leaving a station. So initially the train will be at rest before it starts. Once it starts moving, then the velocity gradually increases as it leaves the platform. So acceleration is nothing but change in the velocity. So according to definition, acceleration is the rate of change of velocity with time. The formula is acceleration is equal to change in velocity by time taken. A equal to v minus u by t, where v is the final velocity and u is the initial velocity. The SI unit of acceleration is meter per second square. Negative acceleration or retardation or deceleration. From the term, it is clear that if the direction of acceleration is opposite, that is, it happens if the initial velocity is greater than the final velocity. That is, if an object is decreasing its velocity, then the acceleration is said to be negative acceleration. We can consider an example of a running race where the students are running with greater speeds. Now, once they cross the finish line, they move with decreasing velocity and ultimately they stop. So after crossing the finish line till they stop, there is a decrease in their velocity. So it is called negative acceleration or retardation or deceleration.
Students, finally we have reached the end of this module. In this module, we have come across those terms which are a bit confusing. Now, it is your task to sit and learn them carefully and understand them. You can understand when you try reading the concept from your textbook as well as trying the exercises and example questions which are given in your textbook. All the best. Any doubts, you can post them in the Google Classroom. Thank you.